Hmm. Hello. Are there any bytes and bits flowing? Let's see. Let's ask all the noob questions. All of the noob questions. It does appear that there might be some bytes and bits. Okay. Well, we're recording anyway, so we'll just assume that all the bytes and bits are going where they're supposed to be going, and that everything is perfect. Hello, my name is Ben. This is Stray Capacitance. My amateur radio call sign is Alpha Bravo 4 Echo November. And this is going to be just a short Saturday reverse engineering stream. Just me messing about a bit and seeing if I can learn anything. Reverse engineering is not my strong suit even by a little bit, and I don't know enough about electronics to be any good at this stuff, but it's kind of fun to screw around with. So I thought somebody else might want to come along for the journey. I'm also screwing around with the streaming setup, and so something's probably going to go horribly wrong. Hopefully not embarrassingly so. We'll see. So if we try out the new bench cam, which should be better than the previous version, we'll see if the stream catches that up or not. Toot toot toot. Hopefully. Oh, I went with normal latency, so I have no idea what to expect on this. But we'll see what we get. So hopefully, yes, it looks like it did finally catch up. So hopefully you can see my bench in somewhat better resolution than last time. Lighting still needs some work, but the interesting introduction here is to Pinhead, the pin probing board. It's a 3D printed probing board off of Thingiverse, and it uses acupuncture needles to actually get in there and get right down into small, tiny places, which is super duper handy. You can kind of see the setup here. I've got the motherboard for a Logitech. I believe it was an M570, but it may have been the previous generation. I'm not 100% sure. But the blue trackball that went with it makes me believe it is the M570 as opposed to the red ones that came in the previous generation. So the motherboard's down in there and clamped down and hooked up to my tiny RF noisy bench power supply, which we talked about a little bit in the last stream. That power supply is not running the headphone amp today, which is hopefully why I sound a little better. So it's supplying about 1.4 volts to take the place of the AA that would normally go into this trackball. And I've got a 10 of the little acupuncture needle arms crammed right in there, trying to get on that flat flex connector. And I believe I've got them all in there. And then each of those is broken out with a piece of silicone wire, color coded because of course otherwise this would be a huge mess, huger mess than it already is. And that goes over here to this breakout board, or breadboard, I'm sorry, that has a breakout to the same flat flex connector, or I believe the same flat flex connector, and then the trackball sensor itself wired into that. But that gives me the opportunity to take those 10 pins and plug them into my Analog Discovery 2 from Digilent, which is a nice little tool. It does a little bit of everything. It's not nearly as fast as a true signal analyzer. It doesn't have the bandwidth of a real oscilloscope. It doesn't have the power of a real power supply. It doesn't have the, capabilities of a full signal generator or network analyzer. But it does a little bit of everything, and for the price, it's an amazing little piece of kit. At least that's my impression of it. I am, as I've said several times here, not an expert, so hopefully it will work out well. So what are we doing? We're trying to sniff the interface between the Atmel microprocessor that's on this board and the trackball sensor. Honestly, the rest of the trackball I don't care that much about. It does, it uh, talks the Logitech uh, unifying receiver protocol. Honestly, not that interesting to me as far as this stuff goes. Um, it, I'm sure, has other interesting capabilities. The only thing I'm interested in is the interface to the trackball itself. And this is the part, the trackball sensor, that I'm hoping to reuse in future projects. So everything else is just there for me to get at the protocol. So let's switch over to the desktop and we'll see if that works. And we can talk about what I've got going on here. I've got some research in the past and some just probing out the board, some trying to see if I can figure out what's going on from, what tracing things on the board and such. But mostly, I'm going to have to kind of rely on the senses that the Analog Discovery 2 gives me to figure out what's going on here. This probably won't be a super long stream today, both because I've been working all morning and because I don't know what I'm doing. And, bumbling around on stream feels, I feel a little self-conscious about it. We'll see if I get over that or not. So here are some notes I've taken in the past. I believe that this is the flat flex connector involved, and here's the DigiKey site for it. We can take a look at their nice 3D model. As you can see, nothing too exciting. One interesting thing is that the pins, pardon me, I'm going to need a cough button, aren't I? In fact, why don't I show you the nice pretty image for a second. Okay, sorry about that. I don't believe I even explained the pretty image, but when do you need justification to do some macro photography? So what you can see there is a macro shot of all the tiny little acupuncture needles down onto that flat flex connector. If we flip back to desktop, as I said, this is the DigiKey connector or DigiKey part for this connector. And one interesting thing about it is that the pins alternate on each side. It's not uncommon on super small parts like this, but that does make it a little bit interesting. And if you see on Pinhead, the probing station, the numbers alternate sides, right? So I did one nearest the front of the bench, and all the odd numbers are on my right, and all the even numbers are on my left, so that it matches the pinout of the connector, so that it matches all the way through the whole chain. And I even, just because I'm not smart enough to keep it straight otherwise, I made sure that pin 1 on the connector goes to pin 1 on the Analog Discovery, not pin 0. Even though, yes, I'm a software developer, I would much rather start counting with 0. That's not how we count pins on connectors, so that's not how I'm doing it today. If we take a look at the data sheet for anyone who's interested, this is a really nice, tiny little part, at least by my standards. So 0.2 millimeter wide pins. I believe it's a 0.5 millimeter pitch. Yeah, nice little connector. Was a little bit fun to solder. Yeah, 0.5 millimeter pitch, perfect. But I managed to hand my way through it and eventually get that settled. I did manage to destroy one when I desoldered it off the Logitech motherboard, but so it goes. So let's take a look at my notes. This is just kind of the OneNote page that I've had running for this stuff. And so we'll start off. There are hardly any markings on the sensor itself. I've got two of these sensors, and only one has any markings on it at all. EL1B, my apologies. 3J08D, and a C. The other one has no visible markings that I was able to find, even taking it out of the plastic shell. So everything here has been kind of experimental, right? So there's also a bed of 8 test points on the bottom side of the board, and I kind of have some information about those down here as well, just trying to keep everything straight in my head. So test point 2 and pin 1 both appear to be plus about 2.1 volts. I can't find any signal on it. It just appears to be the power rail. Pin 2 appears to be ground, probably. Pin 3 corresponds to test point 6 on the bottom of the board, and that goes to pin 16 on the micro, which the documentation calls out as MISO, or master in slave out, in SPI terms. I know I called it SDI on the last stream. SDI is a digital video format. SPI is the serial peripheral interface. Take a quick look at that. And I've not done much with SPI, as I said, as I will continue to say. I'm pretty much a noob at everything, but SPI is a multi-drop topology where, there we go, that's probably more visible to you guys. You can have multiple slaves with one master. The master drives the clock and runs slave selects to tell which slave to tell the slaves which one it's trying to talk to. So you can wind up with the bus being the clock line, master out, slave in, master in, slave out, as the 3 wires of the bus itself. And then you kind of wind up with one slave select pin per external device. So if you've got 10 devices on the bus, you've got your 3 bus pins and then 10 slave select pins. Something like that. There are, I'm sure, all kinds of limitations around it that I don't know about, and I know that there are interesting things around modes and clock polarity that I don't know the answer to in this case yet. So that's one of the things I'll have to determine as we go. So let's take a look at that. Oh, good, even nice graphics. So you can either clock in on the rising edge or the falling edge, right? And you can clock out on the rising edge or the falling edge. So that is a little bit complicated. Slave select is, my understanding is, usually active low. So you pull the line low for the device you want to talk to. And then there's kind of the cycling diagram of when the bytes are supposed to be valid on the bus. And there's a whole description here. I'm not going to read it to you, and I'm certainly not going to explain it to you because that would be irresponsible. I don't understand it. But they kind of boil all that down into these SPI modes, which kind of group up the clock polarity, clock phase, and clock edge ideas. My understanding is that there are some that are way more common than the others, and I don't really know which ones. The only thing I really know about it is that from the Embedded FM podcast with Alicia White and Christopher White, which I deeply enjoy, they will occasionally complain about how irritating it can be to bring up a new peripheral on SPI. Not that it's better or worse than I2C, just or a single wire or a two-wire interface like I2C, but just that they've certainly mentioned repeatedly that there's a lot of magic and voodoo that you wind up learning as you go, and you have to kind of remember that. So one of the advantages of having a career there is I'm sure they know where those bodies are buried, and I get to discover them myself. So that's kind of the high level of SPI. What I've seen on the board, so this was some earlier reverse engineering, and I'm not sure I trust any of this anymore. Getting a connector onto this little tiny thing has proven tricky for me, and this kind of probing station is the first time I actually trust any of my results. So we'll have to see what we get out of it. But this reverse engineering is just based on tracing the pins, buzzing out the board, and trying to figure out what's going where. If you can hear the cat in the background, that's one of our cats, and he's the one who loves to come into Dad's office and hang out. So unfortunately, he can't be in here when the pointy needles are all over the place. And also I've got some cameras hanging around and things to try to support the stream. So unfortunately he won't be joining us today. Maybe eventually if I get a face cam or something, we'll see about getting a Tiberius cam, which will certainly never compete with the Tuco cam, but the internet's always better for more cats, right? So we talked about pin 1 and 2, power rail there. We talked about pin 3, master in, slave out. I believe pin 4 goes to pin 15 on the micro, which is the master out, slave in, the other direction. So again, kind of the way SPI works is when the master wants to talk to a slave, it drags that line low, the slave select line, to determine which one it wants to speak to. It pulls that line low, and then it starts clocking. And it can put data on the bus and clock. And at the same time, it is expected that as the bits get sent out from the master to the slave gets to send bytes up to the master. So my understanding, again, I'm a long way from an expert in this, is that there's a lot of running the bus to just kind of, you might ask the slave a question, you might send the request to the slave, and then you clock the bus another 8 times to give it a byte in which to reply. Because of course, it doesn't know what question you're asking until you've asked it. The byte that it's going to clock out might be the response to the previous question. So you ask it, what's your X position? And then you ask it, what's your Y position? And as part of asking it, what's your Y position, it's clocking back the answer to what's your X position. And then at the end of your cycle, if you need the answer to your last question, you just kind of send it a no-op, a byte with no response required, and that gives it the chance to cycle out those bits. Again, my understanding. Who knows if I've got any of that even remotely correct. But, let's see here. So that's that. So master in, slave out, master out, slave in. Serial clock. Also pin 17 on the microcontroller is pin 5. This pin 6 on the connector is pin 2 on the micro, And that's just, as near as I could tell, uh, data port D4, that bit into the serial, I'm sorry, the microcontroller's output registers. So I'm guessing that's clock select. I don't know. Pin 7's interesting. I buzzed it out as having a capacitor to ground. That would, strike me as maybe a power rail, but maybe it's not. Maybe that's just for denoising the edges and things. I'm not sure there. 8 and 9, I believe, are both ground. And then pin 10, I believe, has no traces on the board. I looked at some pretty zoomed in macro shots for quite a bit, and I could not find anything there. The test pads on the bottom are almost certainly a programming header for assembly. So I'm assuming that this is probably a standard pinout for the Atmels or, very common dev boards or something like that. But it has VCC on it, possibly twice. Seems suspicious to me, but whatever. Has ground, a reset line, MOSI, MISO, serial clock, and then one pin on the microcontroller. And I'm guessing if I went and spent time in the Atmel documentation, which I did some back, oh my goodness, the last time I really got into this, which was probably November-ish, this is how you program an Atmel micro when you're dealing with this kind of a scenario where it's locked into a board and you don't have a bootloader or anything. This is how you get that bootloader into place. The chip itself is an ATmega 168p, and I don't have the data sheet up here because I'm hoping I won't need it much. But that is what drove a lot of the references here. I don't have a good macro shot of the micro itself. Let's see what this camera can do. How about I not screw up quite so bad? Switch over to the bench cam. See what I can see. Oh, are we far out of focus? No, can't zoom in either. Trains. Nope. Okay. That looks like a to-do for me, is getting a good way to zoom in on the bench cam. The bench cam here is just my previous generation cell phone, a very nice Pixel 2, running some software to turn it into an IP cam. And then IKEA lights everywhere to try to get some light on the subject. This is a very small little thing, and I've been using my 7X little cheap loop to even tell if my acupuncture needles are anywhere near where they need to be. So that is always a blast. Don't get old, kids. So what else? Let's take a look at waveforms. So this is the software that runs the Analog Discovery 2. And it comes with a bunch of things it can do. Spectrum analysis, protocol analysis, network analysis, pattern generation, logic analyzer, which is what we'll be using today, just kind of a logger. It'll be a voltmeter. It will do power supply stuff. It's limited to 5 volts, at least powered off USB. It does support an external power supply, which I don't have for it. Just hasn't come up yet. Almost everything I've been doing so far is, oops, if I remember to turn the desktop back on, doesn't it? Almost everything I've been using it for is 5 volts or 3.3 volts, or in this case even lower, 1.5 volts, so it hasn't mattered. As I said, I am using my tiny little RF noisy power supply today in lieu of that, but that was just a matter of convenience. So it will do waveform generation, and it'll be an oscilloscope to a point. It's not amazing. Again, I've got a real scope for when you need to get up into the megahertz range, but at lower speeds, it's okay. So what would be fun? I've been doing some captures here, and you can see stuff happening on the various buses. You can see pin 7, which, if you recall, let's put that over there. Pin 7 I buzzed out as a cap to ground. So I wouldn't expect pin 7 to have a whole bunch on it, but it has a whole bunch on it. So I think I'm probably wrong there. Pins 1 and 2 I took off the trace to save bandwidth because I was running out of bandwidth, as you'll see here in a second. Same with 8 and 9. I did trace those out and couldn't see anything on them, so I took those out of the trace here to kind of give myself a little more bandwidth. Let's get it to be more quieter. Oh, goodness gracious. Okay, so and pin 10 has something going on here. I couldn't find any indications that 10 was connected to anything. And so I suspect what I may be seeing here is the logic analyzer getting a little confused about where ground is. And so things that are floating may just be kind of triggering back and forth over it. So that may be the next thing hardware-wise that I want to play around with. Let's capture something just real fast, just because it'll be fun. So I've got the power supply on. I'm going to turn it off, and you should see if you can see the tiny green LED on the board, kind of over on this edge, it should go out now, and it has for me. I have no idea what the streaming latency is, particularly audio to video. I played around with it some and tried to make it better, but I don't know if I actually improved anything. So, nope. Set this back to simple mode. One limiting factor of this compared to like a big boy signal analyzer, like a logic analyzer, is, of course, it doesn't have nearly the same amount of bandwidth. It's limited to USB. I can't recall for sure if it's USB 2 or USB 3. I have it plugged into a USB 2 hub, and that may be part of my problem. Analog Discovery 2 from Digilent. 2-channel USB oscilloscope. Let's see. I'm not mentioning USB 3, which makes me deeply suspicious that it isn't USB 3. It's probably in the datasheet though, if we wanted to look. We'll come back to it. No point in waiting. So because of all that, it's a little more limited on its sampling rate than, of course, I would like. I would love to have infinitely fast samples, but that's not going to happen. So let's see what we get at 500 kilohertz with 2 million samples. So I'm going to hit record and hit the power just like a quarter second later if I can. There we go. 2 million samples of data at 500 kilohertz. So Nyquist, of course, tells us that that means I'm anything faster than about 250 kilohertz I'm not going to see. But we get what we get for the moment. So there's definitely stuff moving around here. If you look at 4 here, that looks suspiciously like data. Perhaps aliased data, but something moving back and forth. 6 goes low, and as we recall, we'll just flip back to my notes. So line 6 goes low. Line 6 is what I suspect to be not chip select or slave select, depending on whose terminology you want to use. So this line going low would indicate that the microcontroller is trying to talk to this. I believe that the radio for this product is also on the SPI bus. I haven't buzzed that out, but that would be worth checking. So it's entirely probable that we're not the ones getting talked to a lot or even most of the time, right? One of these pins could well be an interrupt pin, and it only talks to the trackball when it feels the need. So here might be the initialization, possibly. And then a little further on here. Oh, no. There we go. You see we're not the ones being talked to during this data burst. And we believe that 4 is master out, slave in. So that's data flowing from the micro out to a device. And this line is master in, slave out. I believe I can label these. Label, add label. That like a Y, that's kind of just a label. That's not the most helpful thing. Delete. I can rename this, but then I get confused about what I'm doing. Let's try that. Give myself a little more space here. There we go. That's what we want. So should have done this before I made anybody else sit for it. Not chip select. Maybe. And again, pin 7 looks suspicious. Looks like there's something going on there, even though I think it's just a capacitor to ground. But we'll have to see. Because theoretically, SPI would just be those 3. Maybe pin 7 is an interrupt. That would make a lot of sense, but I wasn't moving the trackball around, so maybe it's some other device's interrupt. Maybe that's the radio. Not sure. Anyway, so let's zoom all the way back out. Let's see if we've got another burst of pin 6. So we've got a couple. And here is another potentially interesting section. So chip select goes low, and looks like the microcontroller clocks a byte out to us, and we've got nothing to say, so we just send back all zeros. Again, same kind of thing, possibly more initialization. Here's something happening again on the master in slave out line that isn't involving us, right? Our chip select line is not low, which means we're obligated to stay off the bus. You are not allowed on the bus when it isn't your data. But here we can see a bunch of data getting clocked out to us. Chip select is low between here and here. sure I can drop. That's what I want, a cursor. Oop. So this little burst here of 2.6 milliseconds, it looks like there's several bytes flowing out to us, right? And we've got nothing to say again. Or again, that maybe this data is aliased and I missed the important part. Here though, a little bit later, and I'm curious how much later. Oh no, that's again, chip select's not low. So we are not the ones being spoken to. So this is kind of interesting, but nothing, but for the most part, the trackball hasn't said much. We look while our chip select is low. This might be a data burst. No, again, here where our chip select is low, we've got nothing to say. There are other things on the bus talking, but not us. We are not worthy. So let's try running a different sample, and I'm going to move the trackball around. To be clear, I have not validated this setup experimentally yet, right? That's part of what we're doing today. I don't know that all the pins are well connected. I know that in the past I didn't have all my pins in the right place. I wasn't getting signals on all the lines. Getting some wobbling on pin 5, for example, took a little bit. Getting something that looks like it might be data on 4 and 3. All these pins are extremely close together, at least for my old eyes. 0.5 millimeter is not a lot of space. So I've got, validating that these pins are working is also part of the goal. So we'll run another, so I'm going to grab the trackball here, just kind of wiggle it, boop, doop, doo, and I'm going to run another recording. And I'm hoping that there's a bunch more data on the master and slave outline and maybe some more interesting bits. So here we go. Maybe this. Well, again, it's talking to us, but we've got nothing to say. Other people are talking on the bus, but we are not. So I wonder if it's possible that this isn't working, that the micro is trying to talk to us, but is either its questions are going unanswered, or its initialization hasn't taken, or maybe the the fact that the line's getting pulled low, the micro may be doing that. I'll have to look into SPI a little bit to see if I can tell if the microcontroller is intended to pull the line low and then slaves pull it high, so it's pulling it low with 10 kilo ohms or a mega ohm or something, some reasonably high resistance that then the slaves have to overcome in order to reduce noise on the line. So that's an interesting thing. I suspect that I am not having the conversation I wish I was having, right? Every time our chip select goes, we're seeing the line go low, but we're seeing no data. Is that universally true? These are very small bits of data, so I'm guessing that's just noise. Scroll wheels with Ben. Most fun part of the day. Yeah, again, it's just going straight low. So it would not surprise me at all to find out that the master's pulling that low and it's just sitting there, that the trackball isn't responding. So I'm not sure how much more I'm going to do on stream today. I thought the probe board was a little interesting. I thought that the Analog Discovery 2 was interesting and wanted to share both of those. If you happen to be interested in an Analog Discovery 2. I found it to be quite competent for the price, but again, as I've said at least 3 times this stream, I'm very new at all these things, so if your abilities exceed my own, it may not work well for you. But if you happen to be interested, there's a podcast called the Ham Radio Workbench Podcast that kind of talks about projects like this. And when I bought mine, at least, they were running a deal with Digilent, and I believe they still are, that includes, switch back to the bench cam for a second. The Analog Discovery 2 comes with a whole box of stuff, but they have a bunch of different kits. And so I believe the default one comes with what they call their flywire assembly, which is this, that fits into the end of the Analog Discovery 2 and gives you DuPont headers on the far end. And then they give you a bunch of little micro grabbers to kind of connect it into your circuit. But the deal with Ham Radio Workbench includes this BNC breakout board that gives you 2 BNCs for the waveform generator and 2 BNCs for the scope. And the BNC connectors give you some improvements in bandwidth for both of those, for what they can accomplish. And I think also some improvements in impedance matching. So depending again on what you're doing, if you're doing higher speed stuff, higher speed being relative with the Analog Discovery 2, then that may be of interest to you. Speaking as a radio amateur, they were at Hamvention last year and showing off some neat new products. They've got what is basically a big breadboard with an Analog Discovery 2 built into its base. And that, sorry, just realized I must have moved the light earlier. You cannot see the Analog Discovery 2 at all. The breadboard product looked really interesting just for kind of the point of view of always having your instrumentation built into the things you're working on. But I think that's about it. Just take a quick look. It looks like the stream's still running, so that's an achievement by itself. I have no idea how laggy it's been. I apologize if it's extremely laggy. If my, hands were in view 30 seconds before, or 30 seconds after my voice, something like that. As I said, I'm running the phone as an IP cam, so it's bound to be a little laggy. But, yeah. Anyone who enjoys this, please feel free to leave a comment. I'd love to hear everything I'm doing wrong, as long as it's constructive. As I said in my first stream, I'm always eager to learn, but calling someone an idiot doesn't do anybody any good except make you feel better about yourself, and nobody cares how you feel about yourself. So yeah, it's, if you know something about this trackball sensor, if you love the M570 as I do, if you know things about SPI and you see where I'm going wrong, please leave a comment. I'd love to get in touch and learn more things. Other than that, I think I'm going to say thank you all for your time, and for those of you who are radio amateurs,